on the demand of one of my subscriber that please upload the detailed solution of assignment number 3 of structural analysis 1. So I am here with the detailed solution of this assignment. So I am Suraj Kumar and I am starting this video without wasting any more time. So let's start our discussion from the very first question, that is question number 1. So actually the question number 1, question number 2 and question number 3 is contain the same figure, that is this figure. So the real question is question number 3. In question number 3 you have to calculate the deflection at point B. So for calculating the deflection or at point B, you need to calculate the member force due to external loading and member force due to unit load acting at point B after removing all the external forces. So the actual question is question number 3, but to solve question number 3 you have to find the external force member forces due to external load and member force due to unit load. So let's start with the question number first. In this first question, first we calculate the member forces due to external loading only, then we calculate the member force due to unit load. So for calculating the member forces in this figure, so first we calculate the reaction at the support. So since A is roller support, so there is only one reaction happen, that is R1, and this is pin support, so two reaction will be happen in horizontal direction, or in vertical direction. So there is only one reaction at point A. So by calculating by using the equilibrium equation, that is summation of a moment at point E equal to 0, we calculate the R1. This is the R1 that we calculated by taking the moment about E and summation of all the moment about E equal to 0, we get R1 equal to 7.5 kilonewton. Now we draw the FBD of point A. This joint, I draw the FBD of joint A. So from there we get the value of FAD and FAB. Here is the value of FAD and FAB. By how we calculate this? Just by equating the Fx by Ff summation of Fx equal to 0 and summation of Fy equal to 0. So by considering this equilibrium equation, we find the member forces, that is FAD and FAB. Now similarly we draw the FBD or the FBD of joint D from and in similar fashion we calculate the member forces FCD and FDE. How? By equating the summation of Fx equal to 0 or summation of Fy equal to 0. In the same way we calculated the other member forces due to external loading. So this is the external member forces that we get due to external loading, that in AB member 10 kilonewton, BC 10 kilonewton, CE 2.5 kilonewton, and so on. So this is the member forces that we get. This member forces is due to external loading. Now we calculate the member forces due to unit load at point B, because we have to find the deflection at point B. So we have to apply the unit load and find the member forces in each member. So now in the same fashion we calculate the member forces. So first we find the reaction, that is R1, and equating the equilibrium equation at each joint, we find the member forces in each of the flowing member. So we get the member forces. This is the member forces that we got after calculating, this is the member forces that we got. This is very simple state, that this is this we calculate directly from equating the equilibrium equation, that is summation of fx equal to 0 or summation of fy equal to 0. That is also known as method of joint. So we use equilibrium equation at each joint for calculating the member forces, both in the case of external loading or in the case of unit load. So but one thing you kept in mind, that after before applying unit load at any point where you have to find the deflection, first of all remove all the external forces. So remove all the external forces and apply the unit load at the point where you have to find the deflection. So in this way we find the this is the conclusion. So this is the conclusion. The conclusion means what? This is the member forces that we got after applying the unit load at point B. Now you can match the above conclusion by answering question number 2. You can use this conclusion for answering the question number 2. Now let's move on further step, that is to calculate the deflection at point B. So calculating the deflection at point B, here vertical deflection is calculated. So delta V, so we apply unit load in vertical direction only. If horizontal deflection in question horizontal deflection is asked, then we have to apply the unit load in horizontal direction. So here in this question vertical displacement is asked, so we apply the unit load in vertical direction, and the formula is summation of N1 NL upon AE, where N is member force in the following member. In this column member is written, in this column member force is written due to external load. So N represent the member force due to external load, N1 represent the member force due to unit load, and this represent the length of the following member, that is length of member AB, length of member BC, and so on. So B multiply N1 NL and L N1 NL, so we write in this column, and we add this to find the summation of N1 NL. We got the 199.252, but we have to multiply by 10 to the power 3. Why we have to multiply it by 10 to the power 3? Because the length is in meter and we have to find the deflection in millimeter. So we have to convert this meter into millimeter. So we multiplied this by 10 to the power 3, and we easily get the vertical displacement is 2.4 mm. This unit is mm. So in this way we solve this question. Now moving to the question number 4. So in this question we have to find the deflection at which point? We have to find the deflection at point C. We have to find the deflection at point C. So what are the steps to involved in this to find the deflection at point C? First we have to find the member force due to external load, and then apply unit load after removing all the external load, and calculate the member force due to that unit load at C. So now move to the steps. So first we have to calculate the member forces due to external load. For calculating the member forces, here what we do, we calculated here the reaction R1 and R2. How we calculate the reaction? So the structure, all the structure are determinate structure. We can easily find the determinate structure means we can easily find the reactions with the help of equilibrium equation, that is summation of fx equal to 0, summation of fy equal to 0, and summation of mx m at any point equal to 0. From this equilibrium equation we easily find the reaction. So by using the equilibrium equation, we find the reaction R1 equal to 4 kilonewton, R2 equal to 0 kilonewton, and R3 equal to 4 kilonewton. By and now to calculate the member forces, we have to write the equilibrium equation of each joint. So here we write the equilibrium equation of each joint and calculate the member forces in each of the member. Now this is the conclusion, means this is the reaction forces, this is the member forces that we got from after equating with the equilibrium equation at each and every joint. So now we calculate the member force due to unit load applied at point C. So we apply the unit load at C and remove all the external load, and now we calculate the force in the member forces we have to calculate. So what for calculating the reaction force, here what we do, that this structure is symmetrical structure. This structure is symmetrical structure because in the horizontal direction, if we calculate the horizontal forces at this joint at pin support, what you can say easily, pin support, the horizontal direction reaction is 0. Why? Because there is no any external force in horizontal direction. So when we equate summation of fx equal to 0, then we get from the equilibrium equation this reaction will equal to 0. Now so this is symmetrical structure, so obviously R1 equal to R2, so and this is equal to 1 R1 plus R2 equal to 1 kilonewton, and R1 equal to R2, so both R1 and R2 equal to 0.5 kilonewton. This you simply understand by the use of symmetry. Now for calculating the member force, you have the same step. You have to calculate, use equilibrium equation at each and every joint. After applying the equilibrium equation at each and every joint, you calculate the member force in each member. So these are the member forces. So in similar way we make 1 2 3 4 5 column. In first column we use the member, we write the member, and in second column we write the member force due to external load. In third column we write the member force due to unit load, and this is the length of each member, and these are the multiplication of second, third and fourth column. In fifth column we multiply second, third and fourth column, and we use the formula delta V equal to summation in N1 L upon AE, and in this we also multiply by 10 to the power 3 because L is in meter, so we have to convert the length in millimeter, so we get 0.48 millimeter for this question. Now in this way we solve all the question of structural analysis 3 assignment 3. The same procedure is for all the questions. So first you have to calculate the reaction forces, and then member forces at each and member forces by equating equilibrium equation at each joint due to external load and then due to internal load, and then you have to use the formula in N1 L upon AE, summation of N1 L upon AP. So this is the question number 5th. Then this is the question number 6th. You can see if you want to see. This is the question number 6, and this is the conclusion. It means the member forces due to unit load, and here is the question number 7, in which we have to find the deflection that is horizontal deflection. In this question, horizontal deflection is asked at point D, so we apply unit load in horizontal direction, and then by using the formula we calculate the horizontal forces. So in this way you solve the question number 8, question number 9 and question number 10 also. So thanks for watching.